Very pleased to introduce our special guest today, Key Lam, who's going to talk about his remembrances of Fred. Thank you very much, Key.
Well, thank you. I got a rushed email only last week from Tony telling me to try to say a few words about Fred, my personal interactions with him. So I'm not going to talk about Fred's magnificent mathematics like Ty just did and so on, like Ty just did. And I just confine myself to some personal interactions with Fred throughout my life. He and I met, well, I first came to know about him from the Yellow Book, of course, Springer Verlat, volume 533 that he wrote with Lada and May. The title was Springer Verlat, the homology of iterated loop spaces. When I first read it, I was really marveled at the skill that Fred was able to handle spectral sequences where the coefficient system is not a constant coefficient system. It's a coefficient system that twists around, and he had very good techniques of handling it. And since then, he and I met many, many times during various occasions. So maybe here, met here. Unfortunately, my memory is so bad now that I could not figure out exactly what year and what place where these dots are. Okay, so these simply become a element in an ordered configuration space. No, it should be ordered by time. But sorry, I forgot about the time. So I will be just talking about this kind of unordered configuration spaces in Rn, perhaps. Okay, now one of the times I met him was I was giving a talk. And in the talk, I taught the theorem that there are only 4 division algebras over R for finite dimensional vector spaces over R. And these are the only 4. And beyond that, you don't have anything. Very well-known classical theorem. Fred was in the audience. Afterwards, he came up and said to me, Key, what happened if you just relax things a little bit? This is typically what Hans Miller say, fooling around. All right, so fool around with these numbers a little bit. He said that, why don't you take 2 vectors of certain dimensions and multiply them, but not into a vector of the same dimension, but one higher dimension. One higher dimension. Now, I've been working on this one for quite some time by that encounter, and I never thought about if I cannot do it like that, why not go up one higher dimension? Now, Fred, fooling around, immediately said that, why don't you go up one higher dimension? And I said, what for? He said that, well, if you did that, you managed to do it, you solved the Fourier invariant problem. That is a thunderstorm, right? For me, it was a thunderstorm. So let's see. So later on, I try to figure out what was in his mind. Okay, now, so for dimension 16 on, you pair into 17, 65, this is 127, and so on, one higher dimension than the power of 2, all right? Now, what happens if you do have that? All right, fooling around, it doesn't mean that you have to justify yourself. You just fool around with it. What happens you do with it? If you do the Hopf construction on those, you got those elements in homomorphic groups of spheres. Those elements are in STEM 14, 20, 62, and 126, and so on and so on. So now you can figure out what Fred was having in mind. He was thinking that, well, maybe the Fourier invariant problem is like that. These are exactly the Fourier invariant, potential Fourier invariant dimensions. I was really amazed. Oh, but how could this guy think of something like that? Whereas I never thought about it myself. Okay. Now, of course, this is not true, right? You cannot even pair into one higher dimension. You need to pair into quite high dimensions. So this is typically fooling around to no consequence. But please don't get the impression that all Fred's fooling around were of no consequence. In that this may be the only one that would fool around with no consequence. Many others that he fooled around had typical wonderful consequences. I don't have time to mention that much, but one of the things he fooled around during conferences, walking around and coffee in hand and asking people is, well, characterize those groups gamma whose classifying space B gamma is such that its finite dimensional, its vector bundles, which are stably trivial, is just characterized by W1 equal to 0 equal to W2. In other words, any spin bundle over the B gamma will have to be stably trivial. Now, he was asking this question for years. He asked me for at least about 3 times on one of these places. At no time was I able to answer it. But then eventually, full result, in a joint paper that he wrote, wonderful paper with Alejandro at depth. All right, he was able to classify those groups gamma, such phi gamma has this nice property. So Fred's fooling around really pays off at most of the time, and unfortunately, I picked this one that did not. Sorry. I think I don't know whether you call it fair or unfair. Maybe it is not fair. All right. Okay. Now, let me tell you another personal occasion that again, Fred was not actually fooling around in reality, but having been treated as somebody that he can fool around with for so many years, I always felt, even if without at Fred's presence, I always thought that Fred was around and trying to ask me questions. Here is one example of one question that he asked that I was around. Okay, now this refers to this famous red book. Everybody know what it is, and it has many tables. And you do the tables, you lots of calculations in there, not trivial at all. But when you do the calculations and you read all the calculations correctly and solve the extension problem there correctly, you get theorems. All right. So here is exactly one of the whole theorem. This can be called a pre-covariant invariant. Sorry? Oh, my microphone is swollen. That means you guys can go to sleep. Tony is not going to allow you to do that. Okay, all right. Well, there's no time to explain why this should be called the pre-covariant invariant theorem for some reason that I have no time to explain. But this is a statement that is. Okay, so you take a generator of an image of J in the S term, maps this sphere to the N sphere. Of course, Sn maps to the cell by the identity map as well. So you have 2 homotopy classes of Sn. You can form the whitehead product. So you form the whitehead product, beta with this iota n. And Mark's theorem says that this is 0 whenever I have such a numerical inequality. This phi function was the phi function in John Jones' talk this morning. So I don't have to explain. All right. Okay. So whenever you have this inequality, you have that nice theorem about whitehead product. A vanishing theorem for whitehead products. Now, this theorem bothers 3 people in Mexico for a full year. That is Sam Gittler, Sam Feder, and myself. We were both in Mexico. We just try to understand how could that whitehead product vanish? How would that vanish? So we try and we try really hard. Mark's proof was by going to the red book, did a lot of calculations, all this, and read them out correctly, and then fit the calculation into the EXP sequence. That's how Mark did it. Okay. So after struggling for almost 1 year, we came up with alternative proof. This is an inductive proof, same conclusion, working up the series of elements of ImJ one at a time, working up from eta and then nu and then sigma and then eta sigma and so on and so on. Induction proof and the EXP sequence. We got the same result as Mark's conclusion, and we thought very nice. Okay, quite nice. So we wrote the paper and published it. As exactly the statement is exactly the same as on the blackboard behind. Okay, now up to that point, I had no chance to meet Fred. All right, and you allow me to be a little bit vain. All 3 of us were a little bit proud of that. Okay, anybody who can outdo Maholo just by epsilon certainly is entitled to feel pride, to be proud. Okay, so we were very proud of that. But then, knowing Fred, I always imagined that, well, what if Fred is around and if I told him this theorem? Okay, then at that time, by that time, my impression that Fred is almost like a big brother watching you guys on the big screen. All right? The big brother in 1984. watch everybody, see what they are doing. Okay, I imagine that Fred, if he come across this, he will ask me all kinds of questions. And if I really don't go down deep to the bottom of the matter, then I will not be able to make Fred feel happy. All right. So I kept on thinking about this result here. Now, proved by induction, and it was not too bad. Induction really works quite smoothly, but still, I know that Fred will not be satisfied because he wants to go to the deep down matter or deep down substance of the matter. All right, he will ask, what if this, and why is that true? Why is it not true? This is typically Fred. So I really had to imagine that Fred was just next door and kept on knocking at my door and asking questions. Indeed, this paid off. And after a while, I realized that the inductive method that Sam Pitler and Sam Frederick and I proved is really not the best result. There is a way to improve that result a little bit beyond mark. So after thinking for a little while, if Fred was watching me, I was able to reprove this and replace this result by the following. Namely, if you take that homotopy class in J in the S-term and you map it into the N sphere, provided that inequality is satisfied, then the whole thing in ultimate substance is not when you say a Whitehead product, it's not a matter of calculating like this. It's not even a matter of the EXP sequence. The whole thing is a geometric fact that this guy pulls the tangent bundle back here to 3. That would be, I think, that up to this point, that would be the best way to do it. I got to this because, how many minutes do I have? I'm running down. Okay, so that's about that. On the personal side, since I came here in such a hurry, I was really running. I went to my file, I took something out, my correspondence with Fred. Here is one, undated, don't know where it was sent, and it says something like this. Dear P, thank you so much for the book. It was a book that I gave as a present to Fred's 2 daughters, Helen and Sarah, all right? Helen and Sarah have decided that Helen will read the book to Sarah. They will have a lot of fun with it. It was a real pleasure seeing you in Toronto. Right there. Now, I don't know whether I'm seeing him again or he's seeing me again in Toronto. That must be an early Fields Institute gathering for some topology operations, all right? And that book, as I said, I forgot which book I gave to Sarah and Helen. From my vague memory, it could be this book. Most likely, it would be that book, all right? Well, there's only one sentence in that book that's important. That's right there. Right? Il faut chercher avec le cœur. All right. So, to conclude, I say that Fred is somebody who searches with his heart, whether it's in mathematics, whether it's in art, whether it's in humanity, whether it's in bringing up his 2 daughters, his love for Helen. They all represent Fred's search with the heart. Thank you very much.